NENOMATICA, where mathematics meets YouTube excellence. Welcome to this math lesson about polynomial subtraction. Today, we're going to learn how to subtract polynomials using a simple but powerful rule, a minus b equals a plus negative b. Let's first understand what this rule means. When we subtract a polynomial b from another polynomial, a, it's the same as adding the negative of b to a. The negative of b means we change the sign of every term in b. Let's look at a simple example to understand this better. Suppose we want to subtract 3x minus 4 from 5x plus 2. First, we write out our expression, 5x plus 2 minus open parenthesis 3x minus 4 close parenthesis. Next, we apply our rule, a minus b equals a plus negative b. So we get 5x plus 2 plus open parenthesis negative 3x plus 4 close parenthesis. Notice that when we take the negative of 3x minus 4, we change the sign of each term. So 3x becomes negative 3x, and negative 4 becomes positive 4. Now we can combine like terms. 5x plus negative 3x equals 2x, and 2 plus 4 equals 6. So our final answer is 2x plus 6. Let's try a slightly more complex example. We want to subtract the polynomial 4x squared minus 3x plus 5 from the polynomial 2x squared plus 6x minus 1. First, we write our expression, 2x squared plus 6x minus 1 minus open parenthesis 4x squared minus 3x plus 5 close parenthesis. Using our rule a minus b equals a plus negative b, we rewrite this as 2x squared plus 6x minus 1 plus open parenthesis negative 4x squared plus 3x minus 5 close parenthesis. Notice that we changed the sign of each term in the second polynomial. Now, let's combine like terms. For the x squared terms, we have 2x squared plus negative 4x squared, which equals negative 2x squared. For the x terms, we have 6x plus 3x, which equals 9x. And for the constant terms, we have negative 1 plus negative 5, which equals negative 6. So our final answer is negative 2x squared plus 9x minus 6. Let's visualize what's happening when we subtract polynomials. When we subtract polynomial expressions, we need to distribute the negative sign to all terms inside the parentheses. This is based on the distributive property, which means that subtracting b is the same as adding negative b. Let's start with our first example. We have the expression 2x squared plus 5, y minus the expression x squared plus y squared. First, we need to remove the parentheses. We keep the first group as is, and change the sign of each term in the second group. So, we have 2x squared plus 5, y minus x squared minus y squared. Next, we'll rearrange the terms by grouping like terms. We have 2x squared minus x squared, which is x squared plus 5y minus y squared. Finally, our answer is x squared plus 5, y minus y squared. Let's move on to our second example. We have the expression 10k squared minus 3k t plus 4k squared minus the expression 3k squared plus 5kt. First, we remove the parentheses. We keep the first group as is, and change the sign of each term in the second group. So, we have 10k squared minus 3kt plus 4k squared minus 3k squared minus 5kt. Next, we'll rearrange and group like terms. We have 10k squared plus 4k squared minus 3k squared, and we have negative 3kt minus 5kt. Combining like terms, we get 11k squared plus negative 8kt. Our final answer is 11k squared minus 8kt. Now, for our third example, we have the expression x squared plus x plus 1 minus the expression 5x cubed minus 9x squared plus x minus 3. First, we remove the parentheses by distributing the negative sign to each term in the second expression. So, we have x squared plus x plus 1 minus 5x cubed plus 9x squared minus x plus 3. Now we'll rearrange and group like terms. We get negative 5x cubed plus x squared plus 9, x squared plus x minus x plus 1 plus 3. Combining like terms, we get negative 5x cubed plus 10x squared plus 0x plus 4. Our final answer is negative 5x cubed plus 10x squared plus 4. Let's look at our fourth example. We have the expression negative 10z to the sixth power plus 7z squared minus 8 minus the expression 4z to the sixth power minus 3z squared plus 2z. First, we distribute the negative sign to each term in the second expression. So we have negative 10z to the sixth plus 7z squared minus 8 minus 4z to the sixth plus 3z squared minus 2z. Now we'll rearrange and group like terms. We get negative 10z to the sixth minus 4z to the sixth plus 7z squared plus 3z squared minus 2z and minus 8. Combining like terms, we get negative 14z to the sixth plus 10z squared minus 2z minus 8. For our final example, let's look at a more complex expression. We have x to the fourth power plus 7x cubed minus 12x minus 1 minus the expression negative 3x squared plus 7x plus 8. First, we distribute the negative sign to each term in the second expression. So we have x to the fourth power plus 7x cubed minus 12x minus 1 plus 3x squared minus 7x minus 8. Now we'll rearrange and group like terms. We get x to the fourth power plus 7x cubed plus 3x squared plus negative 12x minus 7x plus negative 1 minus 8. Combining like terms, we get x to the fourth power plus 7x cubed plus 3x squared minus 19x minus 9. And that's our final answer. Let's summarize what we've learned about subtracting polynomial expressions. When subtracting one expression from another, we need to distribute the negative sign to all terms inside the parentheses. This means changing the sign of each term. After removing the parentheses, we group and combine like terms to simplify the expression. We need to simplify the expression. Open parenthesis x squared minus y squared close parenthesis plus open parenthesis x squared plus 2y squared close parenthesis. First, we'll use the distributive property to remove the parentheses. This gives us x squared plus negative y squared plus 2y squared. Now we can combine like terms. We have 2x squared terms, so we get 2x squared. And for the y terms, we have negative y squared plus 2y squared, which simplifies to y squared. So our final answer is 2x squared plus y squared. Now, let's look at our second example. We need to simplify. Open parenthesis 4, y plus ax close parenthesis plus open parenthesis x minus y close parenthesis. First, we'll use the distributive property to remove the parentheses. This gives us 4, y plus x minus y. Now we need to rearrange and group like terms. We have 4y minus y, which is 3y, and we have ax plus x. Since x has a coefficient of 1, this becomes ax plus x, or simply ax plus x. Therefore, our final answer is 3y plus ax plus x. Finally, let's tackle our third example, which is a bit more complex. We need to simplify. 1/2 x squared minus 4x minus 1/3 x plus 3 has x minus 1. First, let's group our terms by their degree. We have one term with x squared, several terms with x to the first power, and a constant term. The x squared term is 1/2 x squared, which we'll keep as is. For our x terms, we have negative 4x minus 1/3 x plus 3 has x. Let's find a common denominator to add these fractions. Converting to the common denominator of 6, we get negative 4x is equal to negative 24/6x negative 1/3 x is equal to negative 26x3. Halves x is equal to 9/6 x. Adding these together, negative 24/6 minus 2/6 plus 9/6 equals negative 17/6, which simplifies to negative 17/6. So our final answer is 1/2 x squared minus 17/6 x minus 1. We need to combine the expression. For a squared minus 3a plus 2ab, plus a squared minus 2a plus 3ab. This requires us to identify and combine like terms. To simplify this expression, we'll first remove the parentheses and rearrange the terms so that like terms are grouped together. When we remove the parentheses, we get 4a squared plus a squared, minus 3a plus negative 2a, and finally 2ab plus 3ab. Next, we'll combine the like terms. 4a squared plus a squared gives us 5a squared. Negative 3a plus negative 2a gives us negative 5a. And 2ab plus 3ab gives us 5ab. Now, let's move on to our second example, which is more complex. We have 4 times the quantity a over 4 minus b over 2 minus 1, minus 3 over 4 times the quantity 8 a minus 4b minus 12. This example will require us to carefully distribute terms and then combine like terms. First, we need to distribute the coefficients to each term inside the parentheses. Let's start with distributing 4 to the first parentheses. When we distribute the 4, we get 4 times a over 4 plus 4 times negative b over 2 plus 4 times negative 1. Let's simplify the first parenthesis completely. For times a over 4 equals a. 4 times negative b over 2 equals negative 2b. 4 times negative 1 equals negative 4. Now, we have a minus 2b minus 4, minus 3 over 4 times the second parenthesis. Now, let's distribute negative 3 over 4 to the second parenthesis. We get negative 3 over 4 times 8a plus negative 3 over 4 times negative 4b plus negative 3 over 4 times negative 12. Now, let's simplify these terms. Negative 3 over 4 times 8 equals negative 6a. Negative 3 over 4 times negative 4b equals positive 3b. Negative 3 over 4 times negative 12 equals positive 9. So we have a minus 2b minus 4 minus 6 plus 3b plus 9. Now, let's rearrange and combine like terms. Let's group the terms, a and negative 6a. Let's group the b terms, negative 2b and 3b. And let's group the constant terms, negative 4 and 9. Finally, we combine the like terms. A minus 6 equals negative 5a. Negative 2b plus 3b equals positive b. Negative 4 plus 9 equals positive 5. So our final simplified expression is negative 5 a plus b plus 5. We want to simplify the expression. A plus 2/3 times the quantity 3 a minus 6b minus 9 minus 3 halves times the quantity 2 a minus 4b minus 6. Let's break this down systematically. Our first step is to distribute the coefficients to each term inside the parentheses. We'll use the distributive property, which states that when a number multiplies an expression in parentheses, it multiplies each term inside. First, let's distribute 2/3 to each term in the first parentheses. 2/3 times 3a gives us 2a. 2/3 times negative 6b gives us negative 4b. And 2/3 times negative 9 gives us negative 6. Next, we'll distribute negative 3 halves to each term in the second parentheses. Negative 3 halves times 2 gives us negative 3. Negative 3 halves times negative 4b gives us positive 6b. And negative 3 halves times negative 6 gives us positive 9. Now that we've distributed the coefficients, our next step is to group and combine like terms. We'll use the property of combining like terms, which allows us to add or subtract terms with the same variables. Let's rearrange our expression to group the like terms together. We have a plus 2, a minus 3, which are all terms. Then we have negative 4b plus 6b, which are all b terms. And finally, we have negative 6 plus 9, which are constant terms. Now, let's combine these like terms. A plus 2, a minus 3 simplifies to 0, which is just 0. Negative 4b plus 6b equals positive 2b. Negative 6 plus 9 equals positive 3. Therefore, our simplified expression is 2b plus 3. Let's look at our second example. We want to simplify the expression. 5 times the quantity a minus b times b minus 3 times the quantity a minus b times a minus the quantity 3a squared minus 5b squared. This expression involves more complex terms, but we'll use the same principles to simplify it. First, let's distribute the coefficients and variables. We'll use the distributive property again, but this time we need to be careful with the order of the variables when multiplying. Let's start with 5 times the quantity a minus b times b. We'll distribute the b to each term inside the parentheses. 5 times a times b equals 5ab. 5 times negative b times b equals negative 5b squared. Next, let's distribute 3 times the quantity a minus b times a. We'll distribute the a to each term inside the parentheses. Negative 3 times a equals negative 3a squared. Negative 3 times negative b times equals positive 3ab. For the third part, we need to distribute the negative sign to the terms inside the parentheses. Negative 3a squared becomes negative 3a squared, which is positive 3a squared. Negative 5b squared becomes positive 5b squared. Now let's combine like terms. We'll group terms with the same variables together. We have negative 3a squared minus 3a squared, which are the a squared terms. We have 5ab plus 3ab, which are the ab terms. And we have negative 5b squared plus 5b squared, which are the b squared terms. Let's combine these terms. Negative 3a squared minus 3a squared equals negative 6a squared. 5ab plus 3ab equals 8ab. Negative 5b squared plus 5b squared equals 0. Therefore, our simplified expression is 8ab minus 6a squared. Let's look at our third example, which involves more complex algebraic fractions. We want to simplify the expression. 156 times the quantity x minus x over 2 plus x over 3 minus x over 4 times y minus 60 times the quantity 2y over 3 minus 2y over 4 plus 2y over 5 times x. This looks complicated, but we'll approach it systematically. For this example, our first step is to identify the common factors and simplify each part of the expression. We'll use the factoring property to identify and work with common factors in our expressions. Let's start with the first part. 156 times the quantity x minus x over 2 plus x over 3 minus x over 4 times y. We can factor out x from the expression in parentheses to get 156 times x times the quantity 1 minus 1/2 plus 1/3 minus 1/4 times y. Now, we need to find a common denominator for the fractions inside the parentheses. Using 12 as the least common denominator, we have 1 equals 12 twelfths, 1/2 equals 6 twelfths, 1/3 equals 4 twelfths, and 1/4 equals 3 twelfths. So, inside the parentheses, we have 12 twelfths minus 6 twelfths plus 4 twelfths minus 3 twelfths, which equals 7 twelfths. Similarly for the second part, 60 times the quantity 2y over 3 minus 2y over 4 plus 2y over 5 times x. We can factor out 2y from the expression in parentheses to get 60 times 2y times the quantity 1/3 minus 1/4 plus 1/5 times x. Let's continue simplifying our expression. For the second part, we'll find a common denominator of 60. 1/3 equals 20 sixtieths, 1/4 equals 15 sixtieths, and 1/5 equals 12 sixtieths. So, inside the second parentheses, we have 20 sixtieths minus 15 sixtieths plus 12 sixtieths, which equals 17 sixtieths. Now, let's simplify our entire expression. The first part becomes 156 times x times 7 twelfths times y, which equals 156 times 7 twelfths times xy, which equals 91xy. The second part becomes 60 times 2y times 17 sixtieths times x, which equals 60 times 2 times 17 sixtieths times yx, which equals 34xy. Finally, we subtract the second part from the first part. 91xy minus 34xy equals 57xy. Therefore, our simplified expression is 57xy. That concludes our lesson on algebraic simplification. Remember the key steps we followed. First, distribute coefficients to terms inside parentheses. Second, combine like terms by adding or subtracting terms with the same variables. And for more complex expressions, look for common factors to simplify fractions. With practice, you'll become more comfortable with these techniques and be able to simplify even the most complex algebraic expressions. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.